We're back, we're live, we're Think Tech on our last broadcast day of the year, and we're doing a special today on Hawaii, the state of clean energy. We're going to talk about Amici. Amici MPTS, a mainland company that does technology that is coming into the Hawaii market. Very important that we catch them. It's kind of a scoop, you know. We catch them as they come into the market. And we have on the phone the founder of Amici, who is Bob Block. Welcome to the show, Bob.
Thank you very much, and look forward to this next hour.
Okay. And we have Adil Khan, who is the managing member of Amici. Welcome to the show to you, Adil.
All right. Hi, everybody.
Aloha.
Okay, and at the table with me, we have Sharon Moriwaki, co-chair of the Hawaii Energy Policy Forum, which is a big deal. Okay, and they cause our flagship energy show to be made every Wednesday. This show will be broadcast at 11 here in Hawaii and also at 4 o'clock here in Hawaii. And it'll be put on YouTube, and you can see it on and on, okay? And between us, we have a Rachel sandwich, and that's Rachel Fukumoto, who is from Hawaii Energy, and they do energy efficiency in the state of Hawaii. And she is here, as she is a lot every single week, or every close to that, to talk about some of their programs. And today we're going to give her 5 minutes, as we always do, to talk about their latest Hawaii energy efficiency program. What do you got, Rachel?
So we have another rebate for you.
Rebates, we love
those. So today we're going to talk about the solar water heater tune-up program. So that starts January 4th, goes all the way to May 31st of next year. So if you have a solar water heater, this is the perfect program for you. We offer a $100 or $150 rebate to have your water heater maintained. And so it should be done every 3 to 5 years.
Okay.
Yep. So
what do you have to do to maintain a solar water heater? What do you have to clean or fix or what?
Yep. So just call one of our participating contractors. You can find that on our website as always. But basically what they come in and do is they flush your tank, they make sure there's no leaks, and they change out your anode rods, make sure that everything's working just fine.
Good.
How do you know when you need to do this tune-up? I mean, is it after 3 years, or, you know, I think mine is like about 6-7 years old. I didn't know we had to maintain it.
Right. Yeah, and most people don't know, but it should be done after your water heater is about 3 years old. So, yep.
What happens though that you know, you think, oh, gee, I got to do something about this?
Yeah, usually sometimes your water heater starts leaking, but if not, there's actually an anode rod in there that helps protect your tank from corroding. So you can't see it from the outside of your tank, but these contractors, they know what they're doing, so they'll check for you.
Mm-hmm.
Okay, sounds good. So it's a $150 rebate, and I'll have to pay a little more than that, actually, to get the contractor to come down. But I'm going to get a longer life on my solar water heater, for one thing, and probably, I think what you're saying is it's going to be efficient longer.
Yes, it really does kind of stretch out the lifetime of your water heater, so you definitely want to get it maintained.
So what happens if, like, for me, mine is over 6 years old, and I call them, would they'll be able to fix it so that it's back to, like, ship-shape condition, even if it's that old?
Yep.
Yeah. Oh, okay.
Bring it back.
Oh, bring it back to life. Okay.
Now, at this point in the program, Bob and Adil, we offer the opportunity for you to cross-examine Rachel. You can ask her any tough question. She can handle it. She's well-educated, and she can beat off your hard questions.
No, she spoke about a good rebate for a good application. And hot water solar heaters have been around for more than 10 years. So I think it is a good rebate to offer and a great way to conserve energy.
Very good.
Okay. I think you got off easy on that, Rachel. Well, let's talk about Amici. What is Amici? What does Amici mean, for one thing? And let's talk about the origin of the company and what it's all about. Okay? Who goes first?
Bob, that question is for you. The question is, what does Amici stand for, and how long is it about? Yeah.
Actually, Amici and TransPower are married. And the two companies, Transpower, as Adil could explain, developed and patented the MPTS, a device that reduces the electricity current requirements.
Yeah, let's put that icon, rather acronym on the table right now. That's a maximum power transfer solution, MPTS, and we want to talk about that in some detail. Go ahead, Bob.
So Amici is the sales and marketing arm. So you have on the phone the sales and marketing, and also Adil, the inventor and developer and patent holder of the MPTS technology. So that establishes who the two parties are that are on the.
Okay, and where is Amici located?
Well, actually, it's located in multiple places. Los Angeles, I would say, is one of the centers. I'm in Reno, and so that means some of the development, some of the work is done here. We have an engineer in New York, and we have it's actually in multiple locations.
And how long has it existed, Bob?
Amici has been around a couple of years. Adil, I think it's 4 years for Transfar.
Okay. And let's talk about the technology. Adil, you're a scientist, yeah? What is your training background in science?
Well, I don't want to show a lot of importance on the scientist part of it. I'm an electrical engineer. I'm electromechanical engineering background, and I've been in technology all my life for the last 30 years. And I have focused on bringing leading, disruptive, cutting-edge technologies all through my life. And as with any breakthrough, it is always a gift from God, and it's an accident. All good things are accidents in life. You shouldn't, if somebody claims that, I went to do this and I accomplished it, well, God had something to do with that.
Sure. You can say that especially around this time of year.
That is correct. Yeah, it is the holy time, and we are very blessed. And we were given this responsibility for solving this maximum power transfer theorem that has been around since 1840. It is popularly known as Jacobi's law. And he wrote this mathematical equation for maximum power to be transferred from point A to point B in 1840. And without the computers and the electronics, it would not have been possible. So that is a little bit of background on maximum power transfer solution.
Well, so what does it mean, though? It means this is the way in which you transfer a maximum amount of power most efficiently. Is that what it is?
Yes. Maximum power transfer means that whatever you generate can be used as useful work. Mm-hmm. In today's world, what happens is you need to generate X amount of energy, but what you really use is X minus, say, 30%, which goes in wasted electrical power. Maximum transfer solution recaptures or prevents any wasted energy from happening. So if you need 100 kilowatts of load, you need to generate only 100 kilowatts of power.
Well, that would be 100%, perfect efficiency. Rachel would be happy, I know.
So how does that happen, Adil? I mean, you have to have some leakage, or you have to have some way in which you're using some of the energy to get from one point to another point.
Yes. What happens, the beauty about this technology is it's called impedance matching technology for those technical listeners. Impedance matching is the science behind this technology, number one. Number two, without electronics and a computerized control processor, you couldn't do this. That is why before 2001, you could not have had this solution, because we did not have high-speed computing devices. So it is an electronic computerized device that senses what is the actual power required to do the work, and then it matches it with what power you're getting from the grid so that you minimize the wastage. So as Jay was saying, there's no such thing as a 100% perfect situation in reality. So it is probably 99% efficient. So you waste 1% instead of the traditional 10 to 30% of the power that you are taking to any building or industry or factory that is getting wasted.
You know, it might be helpful, Adil, for you to explain what would happen without the technology. In other words, I have a building, certain requirements, certain demand, and I have a source that may be at distance. Now I don't have, MPTS. I don't have it. There's going to be a degradation on the line. It's going to be an imperfect efficiency. How does that work in the absence of your technology?
All right, let us take an example, okay? Let's say the building you're sitting in is consuming 1,000 kilowatts of energy. That's what it needs, 1,000 kilowatts. When you turn your motors, fans, computers, air conditioners, pump sets, you are using 100 kilowatts of useful power. Now, what you're really generating and purchasing from your utility is 1,300 kilowatts of power. What happened to that 300 kilowatts that the Hawaii Energy generated, transmitted, distributed, and they brought it to the building? So today, you're generating 1,300 kilowatts to support a building that really needs only 1,000 kilowatts of energy. That is what is happening in the absence of MPTS technology.
Okay, now I put the technology on. What happens? Am I now generating less?
Yes, now you are going to generate close to 1,000 kilowatts to support the same 1,000 kilowatts, and you didn't have to change, replace, modify any equipment that you are using in the building. You continue to use everything as though there is no change, but when the MPTS is turned on, you are now generating the same amount of power that you really need to do the work.
So what I get out of this is there's a black box on the power source, and the black box says you don't need to generate 1.3, you can generate only less, 1.0 or something, and so that will save the need to generate that extra 0.3. Am I right about that?
Yes, let me put it in another way. Let's say that you are burning 1 million pounds of coal in a coal power plant to support a certain substation or a application. When MPTS is on in that entire, all the buildings and the load, you'll probably consume less than 80% of the coal that you did before. So you're not only saving energy, you're also decreasing the carbon dioxide that you're putting in the environment.
Mm-hmm.
So how does it work, Adil? I mean, so you have this black box. Is it like a little gizmo you put on? Where does it go in your system, and how does it work? And where do you put it?
I know it is a beautiful question, and I'm glad you asked me that question. Unlike most solutions where you actually have to touch the motors or the lights and the light fixtures and water heaters and boilers, MPTS unit goes in the electrical room where your power panels are situated, and then it is installed on the wires that are coming into the building and feeding the load. So it is hidden and nobody even knows. If MPTS is off in that electrical room, you are still using the power, but you're using more power. When the MPTS is on and it is still hidden, the users don't know, they're just paying less for that same power.
So it's with the utility, it's with the generation of the power, not with the consumer of the power.
No, it is exactly opposite.
Oh.
All the inefficiencies start at the load. They start inside the building. So MPTS is providing the most benefit to the appliances and the equipment inside the building. It is not only reducing the wasted energy in those appliances, it is also protecting those equipment from surges and spikes and other variations That is what maximum power transfer solution happens when you have cool, conditioned electrical power reaching all your devices and appliances.
Okay, so we're looking now at a photograph of an installation that I assume it's a gray box and then a gray connection box, which you guys sent us. And I'm assuming that this would be the equipment at the building. Yeah.
That is correct. MPTS is installed closer to the loads and closer to the high energy consuming electrical panels in the electrical room.
Okay, now what is this box doing?
The box is sensing the input electrical waveforms, the voltage and current that is coming into the building, and it is also sensing the load requirements of current and voltage by all your equipment in the building, and then it is matching the impedance of the source to the load. In a simple word, the ratio of voltage to current that is coming into the building is matched with the voltage to current ratio of the load, thereby creating a plane field so that you are not wasting any electrical power.
So the computer is in the box.
Computer is inside that box. It's an electronic device. It does not consume any power itself. Unlike all the other solutions, it is not an overhead, it is not a burden, it is not an additional load on that network.
So
Okay,
Adil, is that real time so that as my needs change or my use changes, it will send a message to
The source.
The source.
Sharon, I think you should come work for our company because that is the biggest difference between what exists in the world today and the MPTS. MPTS is a real-time dynamic solution, and there is nothing like it in this whole world. Everything that you know of to do a portion of what MPTS does, they're all static, fixed solutions. If the load changes, there's not much you can do about it. Whereas MPTS is constantly adjusting to the power requirements of the load, and it is recovering and recapturing wasted power so that you don't have to use all that power.
Adil?
Yeah.
Adil?
Yes.
Why don't you also explain the power factor and the CHD?
All right, very important part. Maybe Sharon would ask me that question. You see, a big word that is thrown around in the utility is power factor. Power factor is the electrical energy term for electrical efficiency. So efficiency in electrical engineering is called power factor. Power factor means that if you are supplying 100 units of power, a factor, let's say 80%, if the power factor is 80%, only 80% did the useful work and 20% was wasted. So that is called the power factor. So when you turn the MPTS unit on, your power factor is going to be close to 100%.
Yeah,
Close.
but you're still going to have degradation over the line, but because you're matching the source with the load, you're not wasting anything in the process of satisfying the load. Yeah.
That is correct.
Yeah.
That is.
We're going to take a short break, and when we come back, Adil and Bob, we have a burning question going to come from Rachel. And I would be prepared for this because she's been thinking about it, and she's ready to give you some cross-examination on everything you've said. Whoa! We'll be right back after this short break.
Hi, I'm Ethan Allen, host of Likeable Science on Think Tech Hawaii. Come join us every Friday at 2 p.m. when I interview interesting scientists about what they do, why they do it, and why we should all care about it. It's a lot of fun to see. We hear, and you can learn interesting stuff. You'll hear all kinds of fascinating science, and we know you'll have a great time. Hope to see you then. Bye-bye.
Aloha, my name is Kirsten Baumgart Turner, and I'm the host of Sustainable Hawaii at thinktechhawaii.com. We air live on the internet and also on Oceanic Channel 16. I'd invite you to come for a fresh new show every Tuesday from 12 to 1 o'clock. I try to bring on guests that give us a different viewpoint on aspects of sustainability in Hawaii, as well as trying to unpack some of the difficult concepts of measuring and achieving sustainability, particularly with regard to sustainable economic growth and prosperity in Hawaii. Please join us every Tuesday from 12 to 1 p.m. Mahalo, aloha.
Okay, we're back. We're live and have a wonderful time today with Adil Khan and Bob Block of Amici MPTS, which is energy efficiency technology in their company in California. They join us by Skype, and we left a cliffhanger. Our cliffhanger was that Rachel had a burning question. Go for it, Rachel. See if you can stump the chumps.
Oh, okay, let's see. So in the industry, we've heard a lot about THD. What exactly is that?
THD stands for total harmonic distortion, and this is a result of the growing electronic equipment inside the buildings. There is nothing which is not electronics. Your power chargers that charges your iPhones, your iPads, your computers, your fax machines, your LED lighting, all those have power sources, and all those power sources have electronics in them, and these are all source of distortion for the electrical power in your network. And the THD, the more the THD, more the problems in the network. When you hear your secretary say, hey, my computer crashed, hey, this bulb burnt out, hey, this fax machine quit working. In electrical engineering, nothing happens by itself. There is always a cause. And the greatest cause today is the total harmonic distortion levels that increase current content and the spike content that takes out appliances.
Okay, Adil, is this a good time to play your movie? You sent us a movie, and we can spend a few minutes playing it to show this from the point of view of Amici and TransPower.
All right.
Okay, why don't we run the movie now? Okay, we're talking about 17 trillion in global investment by 2035 coming soon.
No music.
And the demand.
So you don't have any
Okay,
sound?
we're going to talk over the movie. So this is the world's emission from the production of electricity. This is really beautiful graphics, I must say. And trillions to implement the COP21 climate. Oh yeah, for sure. This is directly on it. And here's the maximum power transfer solution we've been talking about. And we're reducing CO2 emissions by 20 to 40% with this. And we're reducing energy demand by 20 to 40% also.
Right.
Okay, and it extends the equipment useful life because you're not using it as much by 20%. And protects connected equipment against power surges, which probably also increases its useful life. And it works with existing equipment. That's pretty attractive. You don't have to redo your whole system. And then we have a list of customers, can't read it, but oh well, here's U.S. Air Force, that's a notable customer. You guys have really gotten out on the sales effort. I'd like to hear about that from Bob. And from GSA, major customer. And gee whiz, this looks like an installation. Aurora Mental Health Centers.
Healthcare.
Yeah, healthcare in general, yeah. Okay, and data centers, they use a lot of power actually, and as we said, healthcare. So, and industry in general. Well, of course, if you can save power, make it more efficient, manufacturing, yes, a lot of power being used in factories. And of course, retail with the lighting and all the equipment, transportation, major. Sharon and I talk about transportation all the time. And we need that here in Hawaii. And hospitality, well, we have a huge hospitality industry. And so, so of course, if you reduce use of power, you reduce CO2.
Always.
So you're right in line. And of course, as Rachel says, she always says, this maintenance costs, operating costs, do more with less. It's true. It's a major efficiency point.
Megawatts.
Okay, that was an interesting movie. So
Very
we're coming
good.
back from that now, and I want to pursue some of the things there. Now, these are your clientele and your areas of industry that you can help in. And one of the things that we have discussed in preparation for the show is that you guys are coming to Hawaii. I want to hear about, why and how and who and when will we see you on our beaches, all right?
Bob, you want to take that, or you want?
Well, sure. First of all, I'd like to back up just a little bit on the technology side. One of the most important factors in running an electrical network is the temperatures that all the machinery runs at. And one of the most important things that happens is that the operating temperatures are reduced as a result of the MPTS. So that's just an important factor to understand.
Where is the reduction in temperature?
I'm sorry?
Where does that take place? At the generator or at the user?
At the user.
At the user.
At the equipment that is in your building, the pumps, the motors, the compressors, the air conditioners, every electrical consuming equipment is now subjected to lower currents due to even lower THD, reduction in total harmonics. So harmonic currents go down. Every ampere of current adds to the temperature. So when we reduce the amps, your temperature decreases, thereby extends the life of that equipment.
So all you're doing there is you're reducing the amperage because amperage creates heat. And so the heat is never created. It's not a matter of siphoning it off and putting it somewhere else. It's never created because the amperage is kept at a minimum, yeah?
That is
That's a good way of expressing it, and
Yeah.
good ending. The other,
Well, let me go to this. It sounds from what you've been saying that Amici and TransPower, the system that you have developed is scalable. So you could make a really big unit and you could put it right on a major generating system. You could make a really big unit at the other end. By the way, there is no unit on the generating system, or is there? The unit that we've seen so far.
It's only at the user point. All the equipment we are going to install is in the buildings and at the end user locations.
Okay, so that sends a signal back to the generating system and
That is-
says we need less right now.
Actually, it is demanding less power from the generator when the
it's
MPTS is on.
requiring less.
It's requiring less.
Requiring less. So you don't actually have to send a message.
No.
Well, there's another very interesting point that I'd like to make, and that is that we have a concept called megawatts. And
We have a program element called negawatts. Have something in common. You guys have a trademark on that.
that video that you just saw, but I want to make sure that you understand what megawatts are and why they're important. As we know, the federal government, the president, is pushing very hard for the reduction in carbon emissions. So what a megawatt is, it's a watt not generated because of efficiency. So as Adil was talking about 1.3, that 0.3 being not necessary, so we don't generate it. If you don't generate it, you don't create demand for it. So you reduce the emissions.
Yeah, it's like it's never generated at all. So you're cutting it right at the source essentially by demanding less. But let me go to what you guys are able to do and what you contemplate doing in Hawaii. And we have 15 minutes for the show, and I guess what I'll do is take a break now. And what we'd like to discuss after the break is what you're going to do here. Who are your prospective clients, both in terms of areas in the economy and actual clients, if you can talk about it, and how you intend to help this market. There's a great laboratory in Hawaii. There's a great number of efficiency programs going on, and as you know, photovoltaic is everywhere, and we are into clean energy. That's what the Hawaii Energy Policy Forum is about. That's what this show is about. And I'd like to know how you plan to integrate in that program and make Hawaii even greater than it is now in terms of efficiency and clean energy. So we'll take a minute, and then we'll come back with Robert Block and Adil Khan of Amici.
Hi, I'm your host on Think Tech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, Think Tech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Aloha! How you doing? It's me, Angus McTech, asking you to come join us on Think Tech Hawaii Hibachi Talk. Join me and my two hosts, Gordo the Tech Czar and Enter the Security Guy, every Friday from 12:45 till 13:45. See you on Fridays, and remember, let your wing gang free wherever you be.
Okay, we're back, we're live. I'm here, Rachel is here, and Sharon is here. And on the other end, we have Adil Khan on Skype and Bob Block of Amici Transpower. Okay, so the question left hanging, if I get this wrong, Sharon, you can correct me, is you guys are going to, come and help us build our perfect energy transformation. And as I think Bob said during the break, we have a lot of photovoltaic here. We have a fair amount of clean energy depending on what island you go to. And we are dedicated to building more and more clean energy. So query, where do you guys fit in all of that? What's the plan?
First, I would like Adil to explain how MPTS helps existing solar systems.
Yes, I can do that. All right, very quickly, we have applications where clients are already having solar or renewable energy. Let's say solar energy is supporting that building partially to take some power off the grid. So they're adding clean energy. When we went in and installed MPTS units in those buildings, we helped that building consume almost zero energy. So we get letters from the utility that says your building is using less energy or no energy, so we think your meter is broken, so they start changing the meters. That is what MPTS does in a cogeneration situation wherein you have deployed solar energy.
So if, for example, we would put the MPTS first, so we know how efficient it can be, and then put the solar panels on, we could save even more money. Is that right? Or how would that work? Or do you come in after the solar panels are already up?
The general principle of energy conservation is you first conserve all the energy you can in a building, and then you put the solar energy. But because solar has already gone into the buildings, and solar is only about 15% of what the building can consume. It's very hard to put more than 15 to 20%. That's the most it can support. So you still had 80% that is coming from the grid. So when you install MPTS unit, all of a sudden you can take off 20 to 40%. So with solar and with MPTS, you are now taking off 50 to 60% off of the traditional power source.
I'm curious. A lot of our residents here in Hawaii have solar. I was wondering if it's scalable at all to our residents.
Actually, we are not going after residential markets simply because you don't have enough usage, and then we have not yet developed a small unit to support for the house because the investment has to be low. Because in your house, how many hours do you run your dishwasher or refrigerator or washer? Hardly anything. So even if you turn the whole thing off, your savings is not as much.
Right.
So
Yeah.
20
Well,
bucks a
But
so that's why-
taking Rachel's question the other way, though, how scalable is this equipment, between a small commercial installation, an industrial installation, and a large one? I mean, how small can you handle, and how big can you handle? And, how do you handle the scalability aspect of it?
Yes, the technology is currently now proven to be fully scalable. We started with milliamps in a ballast inside a fluorescent lamp. So we were saving 50% of the power that a magnetic ballasted fluorescent lamp was consuming way back in 2008. So we scaled it up from there now to commercial and industrial applications that can go up all the way to 1000 amps. So you very rarely have any buildings that are consuming more than 400 or 500 amps at a given moment. So we have found that 400 to 600 amps is probably on the higher level of what we need to scale it. So we have MPTS products that are standard. It can be installed anywhere. They can move it from one location to another, and the capacity matches all the electrical panels. The panel sizes universally, globally, come in sizes of 100 amps, 200 or 225 amps, or 400 amps. And you have standard MPTS units, so you can just buy it off the shelf and go install it. So yesterday you are consuming, say, 100 kilowatts of energy. Today you are consuming 70 kilowatts of energy.
Uh-huh. Well, now, we have one large project downtown, a block or two away from our studio here, called Bishop Square. Bishop Square has two major office buildings and is collectively 1 million square feet of rentable space. And I'm wondering how you would handle that. I'm not sure exactly how the power comes in. It may come in two locations. You would have to have a different facility in each location for each tower. And is 1 million square feet, is that within your ability to scale?
Yes, you can even install MPTS in 10 million square feet. The reason is you are not bringing 1 million watts of energy and feeding it at one point. It comes into your main electrical room, and then the power is split into sub-panels, and then sub-panels, and then those sub-panels are actually connected to the different loads. So you simply target the high energy consuming loads in that building, and then install the MPTS unit only on those panels where the wasted electrical power is the greatest.
So you don't have to install it on everything. You can pick your wire, so to speak, and you can decide which area, which input you need this particular technology on. You can leave
Correct.
other inputs alone if you want.
Correct.
Yeah.
For example, right now the customers are focused on air conditioning, chillers, rooftop units, pumps, motors, because those are the high energy consuming and they have a very fast payback. Like in Hawaii, this product will probably pay for itself. Nobody needs to pay for this equipment. This equipment is like an ATM machine that is putting out money. The more you use it, the more money it puts out. So eventually you may make an initial investment, but it pays for itself in like a year to 2 years. It pays for itself.
Yeah.
Now, to install this equipment, do you need special training or contractor, or how does that work?
We went through a lot of gyrations before we patented and prototyped and commercialized the equipment. Have you heard of books for dummies?
Sure.
I use that for computers.
Yeah. I'm not admitting that
So MPTS is a no-brainer. You bring in 4 wires and 4 wires out. So Sharon and Rachel, if they were allowed to install electrical connections, you should be able to install it.
Okay.
All right.
We should probably turn the
sounds
power off before they try that.
I want to go back to the customers that you have already. Do you have somebody so that we could actually see a working model here in Hawaii soon?
Oh yes, oh yes. In fact, you have several YouTube videos customers are putting up, and there's already several links that you could see. So you can go in and probably watch actual installations on YouTube. And very soon, if you want your one of your power buildings, utility buildings, or one of your news channels, or anywhere you want, you could probably start there and make that building energy efficient. I think Bob wanted to add something, so I think we should give him an opportunity before.
What I was going to say on the other side of that, we're working already with many large companies and the government. We are GSA approved, as you noted on the video. We're in NORAD, which is the mountain. I think you probably know about that. We're on Air Force base, and we're expanding all the military facilities. So that will affect Hawaii because you have a lot of military, of course. And as I said, we're working with quite a few quite large companies that would have factories or other facilities in Hawaii. And I don't know of any current direct relationship we have with the customer, but we're working on building a network of customers. So if you have some suggestions on who we should talk with, we'll make sure to get to them. We certainly would like to help increase the efficiency of power in
You actually have your equipment here in some buildings right now?
In Hawaii?
No, we don't have anything in Hawaii. For almost a year now, we have some projects that they are trying to put that in, but the projects are all still on the design drawing table, so haven't taken.
One major agency is Hawaii Energy, which is where Rachel works, and they are for most of the state looking at energy efficient means. And the negawatt. The negawatt is very important to them. So that might be a connection to make very shortly.
Rachel, we need to probably get the first installation in Hawaii in your own office building.
That'd be great.
Use it, and then you can offer rebates to customers.
Yes, that's right.
There you go.
There
We
you
need
go.
to talk.
Well, when we look at those boxes that you were showing us in the snapshots, what are we talking about, though, as an investment?
What's the cost?
We're talking about 10, 20, 50, 100, 200,000? What are we talking about?
Amici Technologies has made it so simple. Amici is the marketing business development arm, and they're commercializing it. They said we need to keep it very simple. Unlike all the other solutions where it takes months to get an estimate, here I can give you an estimate on the online right now, $162 per amp. So every amp of current you want to run through the MPTS unit, multiply it by 152. If you want to do 100 amps, you want to condition it, you want to reduce wastage on 100 amps of power, it's $16,200.
Okay. One last question before we run, and that is, what do you see for the future of this technology? Of course, it was invented in 1840, Jacobi's Law. I wrote that down. So where is it going now? Okay, can you give us a little précis on that?
Yeah, well, I think you like analogies. I noticed that from our earlier conversation. So the MPTS is more like your iPhone for the telecom. Where do you think the iPhone and iPad is going? There's no limits to it. So we are discovering more and more applications for MPTS units, because earlier you used to have voltage stabilizers, surge protectors, power conditioners, power factor correction units. You had all these devices, UPS, battery backup systems, isolation transformers. So now, and harmonic reducers, right? Harmonic current, active filters, passive filters, control systems. All of that now is in one box. So we are beginning to discover more and more applications as the customers are using it, and customers are telling us, hey, we are using MPTS for this purpose, not for that purpose. And we thought we were going to buy this for energy savings, but we are doing it so that we don't have any downtime of our factory. Or we are using it because we wanted to lower harmonics. So we found that your equipment is decreasing harmonics.
Okay.
So that,
do you have patents on these things, or can I copy you?
Bob is adding something.
Can I say something?
Actually, we're out of time, Bob. We're going to have to cut. We have another show, and it's 12:01 already. So let me say farewell, in the thought that we'd like to explore this further with you. We think you can be a really important part of the landscape here in energy. And I hope when you have somebody on the ground or a project underway, you let us know. In any event, we should check back with you on the changes in the technology. Adil Khan and Bob Block of Amici MPTS Transpower. Aloha, and thanks very much. Happy New Year.
Happy New Year, too.
Yes.